Ladies and gentlemen, welcome to this Building Innovation First Conference. I am Ingrid Napi-Choulet, Professor of Real Estate Studies at ESSEC Business School in Paris, where I hold the chair of Real Estate Development and Sustainability, sponsored by Postimo and Foncière des Régions. It's a great honor for me to be here today with you as a master of ceremony of the 4 conferences which will be led today on building innovation. As the academic partner of this new event at MIPIM, we will prepare an overview of all the topics covered during the 4 conferences of the day and the best practice sharing sessions at the Building Innovation Pavilion at level 01. You will certainly see some of our students attending the conference or surveying people to get your opinion about what is innovation for you. So all the day we are going to speak about building innovation, but what is it? What does it mean, really? Let's just find out a little bit about innovation. It seems to be a constantly evolving field, and certainly we won't have so much time to view all the aspects of building innovation. But first of all, what is innovation? It consists in adopting new practices and new ways of thinking and interacting with our environment. In other words, it can be described as a new successful application of innovation which increases performance. That's the key word, performance. So we're talking about performance, and we can link together performance and innovation. In our case, we will focus on building innovation, but also on city innovation. Second question, which performance? The performance of the building itself, of course, but within the next few years, we can imagine, we have seen maybe many pavilions outside Qatar, London, Paris. We can now imagine that it also deals more largely with the performance of the city itself, where buildings are located. Third question, performance for who? Surely for the investors who own the building and look for revenues on a financial side and on a financial performance. But also for the occupiers who live in the buildings and look for productivity and best ways of using the space. So as we can see, innovation means change into new practices, new ways of thinking. And it is the aim of the Pavilion Building Innovation to give you the last experiences in these topics, in this issue. To summarize, under the heading of building innovation today, we will look at the forces and new technologies, and we have a good panel here, new technologies which challenge both the building and the city itself for the future. So building innovation is not only what we can think incorporating latest technologies or materials, but we will see also that building innovation means exploring new process of design and construction. That is the aim of the panel just now. New ways of thinking workplaces, that will be this afternoon, and new ways of interaction between the building and its environment. In conclusion, the challenge today is to increase performance of the building for investors, for users, and for local collectivity. Before we get started with this first panel in this room, let me just give you an overview, briefly, an overview of the program of these 4 conferences. So the first conferences introduced just now the new process in design and construction. And we have invited a panel of international renowned architects and real estate project designers. The aim is to let them give their vision of tomorrow's building. The second conference this afternoon, at the beginning of the afternoon, is about energy efficiency. And we will have a look at the different improvements in these topics, from design and construction to day-to-day management. The aim is to see how innovation can deliver performance to the building for the investor side. The third conference is about humanizing the building. It will take place this afternoon, and we will see how technical innovations can serve the end user's model. We will explore the different impacts of factors ranging from technical innovation to space planning. And lastly, the fourth conference in the evening, named Connect a Building to its Urban Environment. We will see how both owners and users of building can create value and performance through pooling functions such as parking, energy, transport with the local community. How we can help the building interacting with its environment and create an holistic value. So before, I would say let's just start with the first panel, and I'm very pleased to welcome Terry. Terry Peters is an architect, you're a writer, you're a researcher, and your work explores the integration of architecture with the aspect of biology, conception, design, and fashion. Thank you.
Okay, thank you very much for the introduction. Welcome to the Building Innovation Keynotes, and thank you for coming. I think we have a really exciting panel assembled here from all over the world. And I'd like to thank the co-organizers, Pauline Thierry from Lord Culture and the conferences manager, Maud Chevillier, for inviting me to come here today and moderate this session on architectural building innovation. As was said, my name is Terry Peters, and I have recently edited a book on experimental green strategies about redefining ecological design research. And so I'm interested in this panel because it's about how research and innovation is using new technologies and new design approaches to create excellent sustainable architecture. So the format for the session right now is that I'm going to give a very brief introduction to some key themes that some of the speakers are going to be touching on. And then they're each going to give a short 10-minute presentation about their work. And then we have some time for discussion and some of the panelists to respond to each other's work, which is always quite interesting. And yeah, so in my introduction here to the themes, this theme in contemporary practice, this new emerging trend of architects doing research, so beyond academia, but actually bringing research into practice and applying it, is taking place in the work of the panelists here. And for example, the work of 3XN has a research and development group which is doing sustainability research. And as all parts of society are becoming more engaged with technology and aspects of sustainability, of course we're finding this in practice. And it's interesting how architects are responding to this challenge in doing things like internal research groups and also with specialist consultancies like Gary Technologies here. Another theme that we'll be hearing about today, of course, is innovation. And I think we just got an excellent description of how it's being looked at in this context, because it's a very broad term. And here we're looking at, what is innovation in architecture? Surely every project is new, but what makes something truly innovative? And how can that connect to building performance and sustainability? And we're going to be in the panel having presentations about innovation in practice in terms of building, like the products of architecture, but also in design process and how buildings are made and how they're designed. And we'll be able to discuss the relationship of those. And we just talked about building performance and this emphasis. And I think it's interesting to look at the new architectural forms that come out of designing for performance, and also the new ways of representing performance. So examples like this are far beyond traditional plans and sections that architects would normally do, but increasingly architects are analyzing, describing their work in terms of performance in different ways, doing different kinds of renderings, using different software, different technologies. And I think it's creating very interesting communication tools and resulting architectural forms. And one of the themes that will be discussed by some of the panelists, of course, is networks and collaborations and new ways of connecting beyond the traditional design team and the building project team, bringing in new influences, new expertise, and trying to engage with innovation. And sustainability is another huge term, like innovation. And in this short panel session, we're going to be looking at creative ways of being sustainable, new ways of adapting buildings or using new creative tools to design ideas about ecology, buildings as networks, beyond property lines, but actually looking at the site and the different flows of energy and environment, and thinking about new timeframes. What happens beyond when a building is completed? You know, what is the sort of longer term thinking? And now I'll introduce, I'll leave that on maybe. I'll introduce our first speaker. We have architect Kim Herford Nielsen. He's the founder and principal of 3XN in Denmark. Kim graduated from the Aarhus School of Architecture and was one of the 3 Nielsen founders of 3XN in 1986. And last year, the studio celebrated 25 years. And Kim has been involved in all of the practice's major projects, including the Blue Planet in Copenhagen, the Kubus Berlin, the New Museum of Liverpool, Orsdale College, and 3XN, maybe many of you know it, it's one of Denmark's most respected architecture offices. It focuses on cultural buildings, corporate headquarters, educational institutions, and is active in 11 countries worldwide, and it's received numerous international awards, 3 European RIBA awards. And what's interesting is he's going to be talking about specifically the work of GXN, which is their internal research and development group that focuses on green technologies. So it's very exciting to have him here. So thank you, Kim, for coming, and look forward to hearing.
Thank you very much. So we'll see. Okay, good. Well, yeah, we have our department, GXN, we call it, our name of the office is 3XN, so we have GXN, Green Technologies, that where we do research. But I'll start in another way. Start a little bit with what started the whole discussion about innovating. Yeah, it is for people too. So a couple of years ago we had an exhibition called Mind Your Behavior. It's not about telling people how to behave, but more about how all architecture creates behavior. And we analyzed all our latest buildings to see how did they, what sort of behavior did they create. And started with this building that's a building it's Ørsted College building. It's a high school. It's a high school without classrooms. It's a new school reform. And the whole idea about this internal is that it should create interaction between the students, and the students should learn maybe even more from each other. This is the way that they work daily. And it has been a great success. This internal learning environment we learned a lot from. We have made some evaluations of it, and we're coming up with now we're actually researching in the behavior thing in this building here and coming out with a book about it. Because all architecture starts with the users. We are designing buildings for people, so that's, I think, where we should start. And we use this theory on a bank building too that we did in the harbor of Copenhagen. The building to the left is Saxo Bank, and from the outside it's quite something, but it's actually very much what is happening inside. We have an internal staircase combining all the different floors, so people use the staircase instead of taking the elevator. There's 1,000 people working in this 16,000 square meter building, and the building, the bank provides lunch for all the people. So at lunchtime, 1,000 people are going down the staircase. They're not waiting for the elevator, of course. And we have floors flipping from double high spaces to one side and double high spaces to the other side. So everything is very open and very visual. The idea that it should create a team spirit and people should learn from each other, the same way as it should at the college building. And that has been quite an example of other buildings too. And when you come to building performance, the building next to this Saxo Bank building, we did the Horton building, where the client is at a lawyer firm, and they wanted a very sustainable building that in itself, in its form, became sustainable. So we developed a prefab element that is shaped in a way so it shades for itself, so we don't need any sun shading. So when you see it from the south, where the sun comes, you can see no windows, so no sun heat comes into the building. See it from the north, there's a bay window, so every lawyer has got his own bay window looking out to the canal and to the north, which creates another quality for him. But it we proved that forming the building this way, we could save so much energy that they could pay for this extra facade. That is, of course, a little bit more expensive than just a flat facade. And when you do buildings for this, this is another saving bank, for example, for a small community. The building should not have only one function. It could be a multifunctioning building. It has to blend into this small society, of course. But the idea was we wanted to create something that had a social function to it too. So we created a little plaza here on the ground floor. That is the plaza where they have events. They have Christmas trees, parties, and small concerts and stuff like that. So the bank becomes more than a bank. It becomes a community building as well. And then the cladding and the outside is where we come in and like to play a little bit with our GXN, with the facades and the facade materials, and how we design the facade. So it is very sustainable, and we take the sun seed out in the same way that we get the daylight in, and it becomes a feature. It becomes a decoration on the inside of the building, but it has a practical use. It is only to keep the heat out and get the view in. But it becomes something that gives an extra quality to the inside of the building. And the building is created with this open landscape, and where the staircases becomes elements for interaction. So when in the morning when the boss comes to the office, he goes zigzag all the way up through and say hello to all his people before he ends up at his office. So there's a very visual organization inside the building. And as I say, it has a connection to the small society. So they use a little plaza on the ground floor here for an indoor concert, and other times for a flea market for the pension, the elderly senior people. We got an interesting task to do a hotel on a site on a new town outside Copenhagen, next to a conference center. And we had a small footprint, so actually. What the client wanted was just 2 towers coming up, but if you just made 2 straightforward towers, one tower would just look into the other tower. If we tilted the 2 towers, we'd get more value, more views out for all the towers, and that gives 25% more revenue, and it costs 5% more to make the building this way. So that was why the client accepted to make it this way. Even it was quite a challenge to build the building this way here. We had to use mountain climbers because of the tilting of the building. And when you do we're just working on a new big development in Aarhus in Denmark on the harbor side, where I think it's very important when you do a big development like this, that you have a diversity not only in forms and shapes, but very much in the people that comes in there. So there's social housing, there's condominiums, there's a hotel, there's shops and offices. And daylight conditions in Denmark are very important for the quality of the areas. So towards the north, we even have sunshine because we twisted the building so the sun can come to the north side, so we can have cafes along side where the views are as well. Here, one of the last examples here is a museum that we had just finished off in Liverpool that is connected to a very difficult site, a World Heritage site on the harbour, where it has been important to create something that gives something back to the city. It is a lifted up space from where inside and outside can see the city. This museum is telling the stories about Liverpool. So the whole museum is built more like a land art and connected to the site. So you can see your city from different ways. And a cultural building in Norway that connects two sides of the city and becomes interesting in the way that it not only allows you to come from one deeper point of the building to a higher point of the building, it allows you to have concerts and events on top of the building. When we won the competition about the aquarium in Copenhagen that we're building right now, we really wanted to look into new materials and new technologies, because this is a very difficult building to do, and at the same time we had just an ordinary budget. So we used 1 year to look at different ways of building this building with glass fiber or fiber concrete, but ended up with a fairly traditional way. But still, the research was very, very good for us. Just the technology we had to use to shape this building and get it within the economy. And actually, we are now building it to a fairly ordinary economy. GXN, where we are looking into new materials and new technologies, we started 6 years ago. And it's Kasper who's in charge of that. We have now 10 different research projects from new materials like biocomposites. A biocomposite you can use for a building material. For example, this one here, where we did an example for an exhibition at Louisiana Museum, where we had to create a pavilion of a biocomposite, and we created it out of cork, flex fiber, soy, and maize. And we wanted to show that you can do any form and anything with this material that you can do with glass fiber or with steel. And it got this shape like a Möbius, never-ending shape. Cradle to cradle was the idea behind it too. And because of that, we proved that we could do this shape, and it has the strength of glass fiber. We got this big research project from EU, 5 million euros, to research further into the material as a building material. And we got an award at the GIC Composite Fair in Paris for it as well. And right now we are investigating in vertical farming. Here's a project from Stockholm. We call it the Green School, because on the lower floors there's a green school teaching in farming and indoor farming, and we have some vertical farming here, and then we have the school down here. We have senior living here and younger living up here. So we have a mixture of inhabitants in the whole building. And of course we are experimenting with a lot of different issues here. One thing is these strawberries that is hanging from the floor. And we can actually harvest strawberries in this way here 9 times a year. Instead of having grapes up there, that would be only once a year. So that'll be quite interesting, without being a decoration for the building and interesting to look at. It is something that benefits to the building and to the community. So this is the last picture. I'm ending up with. I think this is some of the future things you have to think about. Not so much maybe in Stockholm, where they have a lot of nature, but if you come to Mumbai, or you come to some of the big cities, New York, I think we have to think of other ways to build and to create living environments where you can have vertical farming within the building community too. That could be very interesting. Thank you very much.
Okay, thank you very much, Kim. So our second speaker is Tobias Nolt. He's an architect and director of Gary Technologies Europe. He holds an engineering diploma in architecture from the University of Technologies in Berlin, and he leads a team of architects, engineers, builders to implement design systems to improve design, engineering, and construction performance. He's worked on a variety of design and construction environments, including the new building of the Tel Aviv Museum of Art, the Fondation Louis Vuitton pour la Création in Paris, Raffles City in Hangzhou, and many other projects. And Gary Technologies is an office that provides design and project management technology to developers, architects, contractors, fabricators, and other industry professionals. Gary Technologies was created from the research and development team of the architecture office, Gary and Partners, in 2002, and it's now grown to become an international leader in technology-driven project delivery. And they have offices in 4 continents and projects around the world, with offices in LA, New York, Paris, Doha, Hong Kong, Shanghai, Beijing. And Tobias is going to talk to us about new processes of design and construction relating to new potentials for building innovation. So we look forward to it.
Thank you very much. Let me just start oh no, this is the wrong slide. Oh, sorry. No, that's good. Thank you very much. Yeah, what I want to talk about actually is concurrent design practice, not less about projects, but more about the way how projects are designed or how projects are executed. The introduction told already that we have, offices globally distributed, 130 employees, and the expertise or the competency of GT really ranges from architecture, engineering, construction to computer engineering. And we have people, architects, engineers, mechanical engineers, structural engineers, and also computer engineers working for us. And we have the support by the support of really like world-leading architects, builders, and visionaries, such as Ben van Berkel, David Child, Zaha Hadid, and Wolf Prix. And this GT Builders Collaborative advises, tests, and supports emerging GT technology innovations. And the projects that we are working on, just a couple of examples, are can like deliver significant client benefits on the project. One example being the One Island East Tower in Hong Kong with Swire Property, the Qatar National Museum with Atelier Jean Nouvel, where we provided project management and automation, design automation services. The Louvre Abu Dhabi, where we worked on parametric design solutions and rule-based design. The Yas Island Marina Hotel with Design by Asymptote, we did a whole bunch of 4D simulation and sequencing of the construction process. And obviously the Beekman Tower, designed by Frank Gehry, where we worked on design to fabrication solutions and real-time costing. And the benefits really ranged from 2 to 10% project cost reduction, accelerated timelines, and reduced risk to ultimately make the design process and the project delivery process more transparent. And the question, I mean, like the kind of thing that I want to talk about today is kind of like how, what are the processes that are used to mitigate risk? And I want to talk about 3 key aspects of this. The one is the authoring of design data, kind of like what data is actually produced to plan this building. How do you integrate and distribute the design data, and what potential do you have to computer process and automate certain aspects of the design? With authoring, first of all, what we do is we implement concurrent design system on each of our projects. We manage the model and we make sure that every piece of the project, every part of the project is 3D modeled, and we have a facade model, we have a MEP model, structure model, and an architecture model. And not only as a volumetric expression, but also as all kind of structured metadata, building metadata that comes with it, such as quantitative data about lengths and areas, and also qualitative data, for example, materials, are also stored in the model. And the model becomes more and more not just like a volumetric expression of a design intent, but it carries also all kind of metadata with it and becomes the project database. And these information can be really anything. In this case, we mapped the impact of a maintenance climber on a facade and stored that information in the model as well. And the important thing is that this information is carried by the facade element itself, that the facade element itself knows what kind of kilonewton impact it has on, by the facade climber. And then we can also, it doesn't only exist in 3D, but also is like the database for all kinds of like data extraction and really making the design transparent in a way in terms of, or quantify it and make it transparent and have like kind of like statistic methods to evaluate the design. That's the type of data. Now the question is, how do you make this data available for other engineers, for subcontractors, for the client? And how do you distribute the data so that you actually can look at multiple systems together and do clash detections to kind of really make better planning? Especially what it makes it more and more complicated, and most of the projects that we work on are globally distributed, like complex documents are authored by globally distributed teams. And not only this, they are everybody might produce the data, but it's really complicated to share because different authoring softwares are being used. And what we suggest is, on many of the projects, is that we actually work with web-based 3D models. We centralize the model and we decentralize the access. And what we did for that is we developed a new tool, which is called GTX, which is a web-based collaborative design platform. It's kind of like Facebook meeting project management. And what you do is you actually, the data of different authoring tools are uploaded to the cloud and distributed to web-enabled devices. The data that's being uploaded can be really all kinds of authoring tools, file extensions, and they are being uploaded to and converted on the server side to a neutral 3D format, and then it can be then viewed together on the web. So they can, on the one hand, you can browse it, you can look with your web account, you can browse the data on web-enabled devices, or you can sync the data. That means the files are downloaded and kept up to date on your computer. And it really is kind of like social networking, meeting kind of like project management. You have a profile page with all of your kind of like the project list. You have then projects basically showing the latest changes on a particular project. You can revert files to a particular revision. You can create file sets. You can create releases to release actually data to somebody else. And then most important, you have you can actually view files that have been converted to this mutual format in 3D on the web, which it's kind of this mutual format that allows for measuring, for dynamic sectioning, red marking, or data extraction. So all of the data that I described before is actually available on the cloud and available on this like web interface. And if you're curious, you can like see it on gtxsync.com. We are currently in an open beta testing phase and using it actively on our projects. So that leads me to like the third part, because when you think about, you have all of the data, you have the data centralized. Now, what are the kind of aspects or like the things you can do to actually take advantage of having a model on the cloud and using cloud processes to automate certain aspects of the design? You know, and how you can actually use cluster calculation for analysis, extraction, and design optimization. And I mean, you can imagine, you have the data up there. For example, drawing production. You can keep kind of like drawing sets up to date. And you can use, just on the server side, really heavy and powerful processes to do so. I want to just show a couple of examples where we actually used optimization techniques, or really heavy processing techniques to increase kind of like the design, like to increase the performance of the design process. And one example being these, on the Louis Vuitton Foundation, we were challenged with the rebuilding of these design glass surfaces, and integrate and build them out of discrete glass elements. And what we did in this case, we built parametric design components that would integrate installation constraints, fabrication constraints. About it, what you see here is kind of glass bending, and integrate them into parametric design component, and then just let the computer negotiate all of these different constraints and come up with the best fit. And we really went through like millions of iterations and had the computer basically solve that problem, this like nonlinear problem, on the cloud. So we had kind of like the local model, but then remote clusters would just kind of optimize the design. And as I mentioned earlier, obviously the component, all of the metadata that I was talking earlier, is embedded in these models. So you have actually, whenever you produce a design variation, you have statistical information, you have self-embedded drawings, so you can actually produce the drawings whenever you found a good fit. And we did that for another facade system on the same thing, where we took these fiber cement facades of 22,000 unique panels. And we built, again, unique components, or parametric adaptive components that would enable us to produce really 22,000 unique shop drawings, really having integrated all of the fabrication constraints and produced 22,000 unique shop drawings. And it was very similar, and you know, I'm getting very close to the end, on the Louvre Abu Dhabi, where we also, with Biro Happel, produced a parametric design model of the big dome with all of the 10 layers. And what we could do using kind of parametric and really kind of automated systems, we could produce design variations, and each design, and always have kind of quantitative control over each of the design variations that we produced. And the variance in this case being kind of like member thicknesses, member length, on each step, we had access to the quantitative data behind it and could really properly evaluate the design, and then produce high-fidelity bidding documents. In this case, statistical information about all of the different members, and then also documents, computer-generated drawings of every single member with unique IDs, every length tag, every measurements were also computer generated. And then in the end, I'm going to skip this, it doesn't really matter. As soon as you kind of describe a design problem parametric rule-based, it doesn't really matter how you kind of apply it and how you use computer processes to find optimal solutions. In this case was with the architect Snøhetta, where we worked on a urban design plan, and what we were challenged with finding optimal distribution of certain urban functions within the city fabric. And we did the same kind of very similar approach, whether or not, you know, approach of like a facade system we applied to kind of urban design, where we found best fits for the distribution of urban functions. Thank you very much.
Great, thank you very much. That was really interesting. Our third speaker is the architect Thomas Wilmot from Graft. He's the co-founder of Graft Architects, and he studied architecture at the Technical University of Braunschweig and took a masterclass for architecture and urban planning at the Bauhaus Dessau. The office was established in 1998 in Los Angeles, and it was conceived of as a sort of label for, quote, architecture, urban planning, design, music, and the pursuit of happiness, which I think is quite nice. And the core of the office's work revolves around architecture, but it always has this interest in crossing the boundaries and disciplines and grafting their creative potentials between different disciplines. And so the office has works in exhibition design, product design, art installations, academic projects, and the office has won numerous national and international awards, and they employ 100 architects and artists worldwide. And they have offices also in Berlin and Beijing. So we're very pleased that Thomas will be here to speak to us about experimentation and unconventional approaches to architecture and design overcoming boundaries. So look forward to hearing. Thank you very much.
Thank you. Let me just open my presentation. Yes, thank you very much. While working globally on different locations, on different continents, I have to tell you, that taught me quite a bit about how different local conditions can be and how much you have to relate what you're doing to the local context. Because one piece of architecture in one continent, one location can be right and can be completely wrong in another location. And that knowledge and is very much the fundamental base for our discussions when we talk about sustainability and the perfect integration of the architecture that we're doing in the natural environmental environment. But I would like to meditate a little bit on the word performance that had been mentioned before, also in the introductory speech. Because I think it's not enough to talk about the technical performance of a building, and I would like to show you a little bit and be very honest about that. This inspires a lot of the formal language that we're using, but the real source for the development of our architecture is another kind of performance. And I could not agree more with Kim in saying that the basis for everything that we're doing is the human being and the way people perform in architecture. So also the way architecture creates a set design or is a set dressing for our rituals, the way we behave, with the way we communicate to each other, that is very much more inspiring or can be very much more inspiring to come up with new and interesting ways to think architecture. And when we started in the hospitality industry, in the hospitality market, so to say, in designing hotels, we were very much inspired by rethinking lobbies, how people interact, very much interested in avoiding vertical walls that separate spaces from each other. Very much interested in creating accessible environments that invite people to like sit on them, dance on them, and so on. So when you look at this hotel that we built in Berlin, there you will see that the floor folds up and it's cut into pieces, and benches and seats fold out of the surface, just in order to avoid that people feel like exposed in a space and invite people to really access it. And that's the basis for many of our designs. When you look at, for example, this hotel room, where we're not talking about like, is that too much of an open space for a bathroom in a hotel room? No, we look for the new rituals of being in a hotel room where the bathtub is maybe next to the bed, because it really inspires people to live in a hotel room in a different way. And that's not reduced to only hospitality and hotels. We try to do that everywhere, wherever we can. When you look at this project, this is, you might not expect it, but it's a dental clinic in Berlin. And the reason to go for a very ambitious design and very friendly, open, colorful atmosphere was, of course, to a very simple reason to take away the fear from the people. Everybody knows that. So when you go to a dentist and come in there and it's very positive and you feel like you can look into all the treatment spaces, it's very transparent, it's a very light atmosphere, and the architecture invites you to access it, to really touch it and behave in it differently, then I think we achieved the goal that we were trying to achieve. For example, here you would be sitting in the waiting areas, much more like sitting on a beach. That was actually also the metaphor behind when we designed the whole space. You would find maybe a campfire in the space, and in the end, in the evening, that clinic seems to look more like a bar or a restaurant than a dental clinic, which I think is very nice. It always has to go well together with also the service component and the way you operate a space like that. That dentist, for example, also treats people at night, so you can go there, get a drink, a whiskey maybe first, and then you go to the treatment. So I think we have to cooperate with operators and be very flexible and inventive also, because it really matters. We have been asked after this project by the biggest hospital, the most important hospital in Berlin, the Charité, to help with the project in the intensive care units. They found out, the doctors found out that when you have too many stress factors in these rooms where you wake up after an operation, then the healing process comes to an end. They call it the delirium, a status where you kind of stop healing. And so they asked us for help, and we're part of a research program to find out how you can reduce these stress factors, like take out all the noises, alarm signals, work on the lighting and so on, really look very closely to what the patient is looking at when he's laying in bed. So we came up with the idea of a screen that surrounds you, that can be that can be interactively used to distract you from like looking at one little angle between the wall and the ceiling for 3 hours, or count the little holes in the acoustic ceiling. Doctors told us that some people do this, and then tell them later that it has like 20,230 holes in the ceiling, and stuff like this. I mean, really look at how you really relate to the space, something that we're really interested in. That just as a little excursion, and now I would like to switch over to that topic. How do we relate buildings not only to human beings? That's more the internal atmospheric question. How do we relate our buildings to their environment? And you might not expect it was also new for us, but we decided for a project, for example, in Addis Ababa, for a hospital, again a hospital, to not go for normal, you could say international, traditional building technique, concrete, but we started to produce and manufacture our own building material, which in this case is thousands of clay bricks that we produce every day. And we try to give a renaissance to a very old construction technique in Addis Ababa, and try to find ways to build trusses out of bamboo that you find everywhere in Ethiopia, and to come up then with a very nice, also interesting piece of architecture that I'm not want to talk about too much. But the important point for me is that sometimes innovation means also to rediscover things that had been forgotten, very, very low-tech knowledge that is there, that can be easily used. And it's more about being smart, not too much to invent too much. And in some cases, you might even find that while doing so, in the end, you end up, and that's the hospital and the aerial view, with forms that very much relate also to the circular houses in Addis Ababa and so on. So this very particular study of a location can lead to very different types of architecture. For example, in this case, in a little residential project, a winning entry for a competition in Kuala Lumpur, a house that is sitting in a park, in a spring and autumn very hot and humid climate. So we came up with the idea of an outer envelope that is open, made out of louvers, that creates shadow for the little boxes that house the real spaces of the house. But these louvers have also another use or function, because they bring in a breeze that, like a little bit of wind, into that envelope that's constantly there in that area. So when you look at the little diagram in the top left, then there you see that we have little water basins on top of these cubes that are sitting within this envelope. And this water gets cooled down by this breeze. That little gap, that little difference in degrees Celsius, cools down and activates the ceiling above you. And by this, we can reduce the energy that is needed to cool down the spaces by 90%. So it's sometimes just a very smart way to use the local conditions that inspires or can inspire completely new forms also, which we're interested in. And you could go even a little further, also recalling what former Foreign Minister of Germany, Joschka Fischer, said this morning. I see a very big potential also in the need to reduce energy consumption and blah, blah, blah. But I would even go a little further and say our buildings can be the power plants of today, or they should be. They should be generating energy. We're not very far from that. I mean, everybody you speak to will tell you this. And we have to be smart and also proactive and very optimistic at the same time, I guess. So when you look at this building that was designed for Dubai, that is already in its orientation west-east, tries to minimize solar gain in the morning and in the evening, where you really heat up the building by the sun, but on the other hand provides a large roof. The whole envelope gains energy. The roof is filled with low temperature solar thermal collectors, so we generate all the hot water that's needed there. On the top of the buildings, we have these lower left image, the high temperature solar thermal generators that in the end produce energy. And also the shape and the form of the balconies is designed according to the parameter of the curves of the sun, so perfect shading for all apartments. So the last project I want to show you is basically focusing on this aspect, that architecture can be a power plant, that can really generate energy and power. And this is something that goes beyond also our design services as architecture, because we have become producers of a little mini house, a solar kiosk, which is meant to bring energy to off-grid areas where you don't have power supply. You know, most of our work, of your work, of my work, is done when you look at the world at night in the illuminated areas. Let's focus for a moment on the dark areas. Also because many people say 50% of humankind lives in cities now. Nobody asks why. Why do people leave the rural areas? Very important aspect to focus on also in the future. Big investment potential there, I think, which we try to dig into with this little kiosk that sells energy, that produces energy, has a battery, has a little fridge, 12-volt low voltage fridge running, internet connection, light at night, as a modular system that can be done in different sizes, simple frame that always the same, can then be closed with different materials, also locally produced. And what we're looking for is to improve that situation in a very typical village here in Africa that at night turns into pure pitch black darkness. And we try to bring in this little one component that might change a little bit of the social life, that might bring enough energy for kids to do their homework after working during the day, and so on. So we're trying to really go for this, and we're very much in line also with your offices in trying to do as much research as possible, trying to work together with consultants as closely as possible to come up with these complex ideas. That's our prototype. We're going to build 6 of them in Ethiopia in 2 months. And we hope that when you ever get to the countryside in Ethiopia, that you will find a kiosk like that and don't have to drink warm beer, but have a cold beer, which absolutely doesn't exist right now. So we hope that while crossing the boundary of architecture, we can do something to also be a little bit part of changing the world for good. Thank you very much.
Okay, thank you very much. That was very interesting. The next panelist that we have is Ma Yansong from MAD Architects in China. Ma Yansong founded MAD in 2004, and his works have been widely published and exhibited. He holds a degree from the Beijing Institute of Civil Engineering and Architecture and a master's degree from Yale, and he's taught architecture at the Central Academy of Fine Arts in Beijing. You might have heard of the office. It's won numerous awards, such as the 2006 Architecture League Young Architects Award. And in 2010, he became the first architect from China to win an RIBA fellowship. The office works on projects ranging in scale from conceptual artworks to mixed-use architecture. And by the end of 2012, 8 of the office's projects will be built, including the Hutong Bubble in Beijing, the Ordos Museum in Inner Mongolia, and the Absolute Towers near Toronto, Canada. And the studio approaches all of their projects, from residential complexes to offices to hotels to cultural centers, with a sense of community and orientation towards nature, offering people the freedom to develop their own experience. So he's going to speak today about building visionary architecture in China and the need for memorable spaces. And he will discuss how to go beyond the demand for comfort and actually argue for coexistence with nature. So, welcome.
We have too many projects to show here, too short. But I'm going to show the slides for 5 minutes, and I have a short video showing our tower in Mississauga. The mayor of Mississauga is here, I'm honored. Here's the tower we're building in Mississauga, Canada. That was a competition we did 5 years ago, or 6 years ago. We won the competition. The competition was for only one tower, and then they all loved the tower, and all the units, 500 units, they sold out in one day, and then they built another one. And the local media called the tower Marilyn Monroe because of the beautiful curve. And then we had to figure out the technology, because innovation always related to technology, but we are not really interested in technology, I think. Using simple technology or feasible technology to make something new is a real innovation. I think nowadays a lot of people are being slave of technology. So that's why I think you can see a lot of boring buildings, win a lot of green building award, but I think in 10 years, 20 years, those buildings will become outdated because the technology, that's the nature of technology, will outdated soon. So in this building, we're using very traditional technology. We're using street core in the middle, concrete shear walls for the building. So these are 2 buildings taking shape and shape the skylines. The shape actually composed by every balcony on every floor. The balcony is rotating on every floor. So on every floor, you have a beautiful view around the tower. At the same time, those balconies can provide very simple sun shading system to the building. So we don't have an expensive 3D curve in this building, actually. Every piece of glass is flat. And we're using window system instead of curtain wall system so that we control the cost, so that this whole project is feasible. I like this photo. You can see the contrast between this tower and the conventional boxes. the conventional box is all about volume, height, and showing the power, strength. I think that's something wrong with our city. Like modern cities, we're building high-rise to show your capital, showing your power. So the whole modern city is about a competition. It's about competition between people or competition between people and nature. But here we think maybe in the future of the city, we should introduce more nature into modern architecture. And here you can see the urban space between two towers. I think that's also unique because everywhere when we want to build a twin tower, they copy two. So make one tower next to another. They're same. Here's a lovely painting from local kids. I'm sure they love the tower. So I like the building can integrate with the local culture. Here's another tower we're building in China, in Tianjin. It's the MGM hotel and the office inside. It's a 358 meter. And the special thing about this tower is that the facade. We're using this honeycomb shape sculpture units, 4,000 of them, to compose the whole tower. So in this tower, there's no column. So we only have a central core and the skin. And the skin actually responding to the climate around the tower. So we have a different size of the opening. So here the space in the office space, you can see there's no column, only the wall. We're also using the window system to lower the cost, also to provide a lot of solid wall to make the building temperature under control. Here's a mock-up. You can see the units of each honeycomb. Each one is a 1 floor height, and they produce in the factory and bring to the site and compose them, so they can finish the tower in very short time. Here's another project in China. It's a museum in Inner Mongolia. It's like a spaceship landing on the desert. So the landscape is a desert where we have this open space. A lot of people come. It's a very cold place, so we're using a lot of solid wall. But inside, we're bringing in this very strong natural light to make the inside warm. And here, the canning-like space in the middle of the museum. So there's a public lobby, where people can come into this space without entering any exhibition. So actually, a lot of people come here. And you don't need any artificial light during the day. This is a beautiful mountain scenery in South China. So we're building architecture in the same region. It's a resort, apartment development. It's a wall type building, but it's huge. It's 800 meter long, 100 meter tall. And it's literally look like a mountain. We actually draw this skyline and transform to a building. And the rooftop is all green terrace. We also have a tennis court on the top. But that's only density you can find in China. Every compound, they look like 1,000 people, 1,000 families live together. And they all have an ocean view. That's a construction photo. Again, the technology we use is very mature. And here's another development. We're building in a mountain area. And we take the program into pieces and blending into the mountain. And we take the contour lines from the landscape and make them buildings. So you can see the tea field we preserved. And the building, we're using this contour lines to transfer into balconies. So every floor, every unit, they have a big terraces. to look at the beautiful lake. And here you have to, there's a water feature. You approach this elevator and go down to your units. So for us, I think the integration between nature and architecture is not only about putting green or using expensive glass. It's about whole experience in the architecture. I think space making great architecture, making timeless architecture. So you go there, you feel you are part of nature, you love nature. I think that's the whole point. This opposite example, I don't really like this. It's a CBD or building in Amsterdam. It's actually everywhere are building CBD like this. Many cities in China following this typology, towers isolated from each other. So actually every tower was designed by great architects, but in the end they have to only do facade because the master plan was so boring. So we were thinking in the future, is there a way, because we all know we like gardens, we like a green, rich people, they live in the suburb, nice garden, but is there a way to integrate this into high density urban context in the future? Because we are building towers. I think there's a way, probably we can do this. We do serious mountains in Amsterdam. In every tower, we have a roof garden. We have this nice balconies. We even have a real mountain there. So that's the proposal we did. So another one in Rome, we're also doing a renovation. On this building, we take all the wall down, so we have only keep the floor and column. And we build this new facade and recess from the edge. Then we're creating a lot of gardens. So every people live in the units, they can live very closely to the garden. Okay, next one, I'll show the video. Can we have a sound, please? So all the design came from imagination of human beings. So the building looked like organic life.
We are attracted as human beings by great design.
People are proud to live in a building that makes an architectural statement.
An architect is an artist. I think people enjoy the work of artists.
It's pretty obvious that people are into design.
Good design not only sells, but it sells at a premium in the marketplace. Well, we always knew that this parcel of land at the corner of Burnhamthorpe and 10 was an important intersection for the city.
The location is center ice within Mississauga. The developers had wanted to do something very special.
We felt that the highest and best use would be a residential building. And so one day I happened to be golfing with Ed Sajaki. I said, Ed, what about an international design competition?
And we were very excited when they said they were giving consideration to going to an international design competition. My staff fully embraced this idea.
I was excited about it. The staff was excited about it when we heard what Fernbrook and Citizen were going to do with an international contest.
It was an idea that took on a life of its own. None of us could have anticipated the response that it would receive, not only from the city of Mississauga, but globally.
Something new in architecture.
Il condominio dovrebbe diventare il simbolo. 通过这幅图想象一下，我们今天请到的。
I like the Absolute for a couple of reasons. First of all, I like the way they did it. The fact that there was a competition. I've never heard of such a thing.
No one believed that a private sector company would ever do that, expose themselves in such a fashion. Not only did it bring this cross-section of designs from all over the world, it brought attention to the project on a global scale. And it wasn't long before we received well in excess of 600 registrations. And from there, we received 92 submissions.
We never expected to have such a result. We were overwhelmed.
And then it was left up to the jury to decide who the finalists were.
There was ultimately 6 that were shortlisted.
We kept the finalists under wraps up until the time of the presentation to the public. and we had a ceremony at BCE Place. The finalists were then presented to the public.
That same exhibit was basically taken on a bit of a road show.
And the public was asked to comment on what their favorites.
Okay, thank you very much. That was a really interesting lecture. Okay, we have a few minutes to have a little panel session and a discussion where the panelists can respond to each other's presentations, and then we can take a few questions from the audience. Yeah. So maybe we could start with talking about just what was in the video here about research having value and how to communicate research and sustainability as being part of what architects do and how architects add value to a building. And in the first presentation, Kim, you talked about how GXN is engaging with different projects in the office. And you showed some examples of how you're creating new materials that can actually add value to the project. Could you talk about the example of maybe the Horton building, of how GXN worked on that?
Hello? Okay, it works. Good. Yeah, it's a prefab building. So we do everything more or less in Denmark in prefab, even the concrete construction. So we had to come up with a solution that was a design and build. So we had a limited budget. The only way to convince the client was that we could benefit something else out from it using less energy in the building. So we got our engineers and GXN to look at how can we benefit from this? How much can we save in energy? And if there's a payback period on 10 years, there's no problem. 15 years is discussable. 20 years, forget about it. So that's what we learned for all our projects. So we proved it could pay back this extra cost for the facade within 10 years. This is made of glass fiber and polyester. In the future, and this is what we're aiming at, we would like to make it on a very sustainable material. Mm-hmm. That's why we are researching in the biocomposites. And I think that will be the future. So it will not only save energy, it will be a very healthy building too.
Mm-hmm. It maybe links back to the project that you showed in Mississauga, where you're actually using the form of the building to shade the building rather than having some external system. And I liked what you said about how if you base a building on a technology, of course it will be outdated because you base a building on design, on design principles. So how does your office do research into, do you have a group of people that do research, or is it project to project, or how do you use it?
There are a lot of people doing research that better than architects. So you work with them. GT people also, R people, a lot of people. Mm-hmm. But architects has their own thing to do. Mm-hmm. You do innovation. What's the innovation about? I think innovation is about how people live. Like we have to see the crisis, have problem of today's city. What's the future city should look like? And I mean challenging technology. I mean people now going to Mars. I mean not by architecture. I think building super tall, for example, is not like cannot compare to 50 years ago when you build a high rise. So what's a new challenge? I think when we talk about green, for example, I think it's more like a moral issue than technology issue. So, for example, I see a lot of green building award, maybe good technology, good material, but people still work in their cubic space, behind the glass wall, isolate from outside. They still want to get off the work and go to their suburb house. What's the problem with those buildings? I think if we talk too much about technology, we'll lost the sensitive part to the innovation.
And when we were talking about collaboration and sharing and communicating information, one of the really interesting things that you talked about was how this new web-based system of sharing data and sharing information. And what do you see? Do you see that as the new direction for technology and design?
What I think is that we will
design these buildings or design cities, it becomes more and more complicated, and it becomes more and more knowledge has to be integrated in one consistent model. And I think that the aspect, and especially if it's like globally distributed teams, the aspect of the management of this organizational complexity is really is a real challenge. And what we are interested in is really exploring social networking techniques on the one hand, and also just exploring digital design techniques or digital processes to help with the improvement of the design and construction of buildings.
Mm-hmm. And in the work of Graft, are you finding that your collaborative way of bringing in, all of these expanded people into the design process, is how do you see research as sort of being engaged with in your practice?
It really depends on how you define research. I mean, you're
Excellent.
doing research like every day. When I'm sitting here listening to you guys, that's research for me.
Yeah.
But I don't think there needs to be a particular R&D department in the office, but there needs to be a certain attitude. And I think that the attitude and the role of the architect is dramatically changing. I think we're going to see the architect who's just in brackets, designing disappear. I think we need to understand that we need to bring, as you said, bring together so many aspects and try to moderate the complexity, try to bring all this different knowledge to the table and have a different attitude of integrating these aspects, and not just standing outside looking at it and then design, or waiting for somebody to ask us, okay, now the building is done, or the concept for an investment is done, now I want you to shape it. I think we have experienced that so often, that developers came to us and asked us for the right concept for a hotel, for example, and I think that's a good thing. Why shouldn't you embrace it and try to at least be the generalist? I mean, get as close as possible to the Renaissance generalist. You will never get there and be a specialist for everything, but we should definitely not be only specialists for design.
Mm-hmm. I liked how each person on the panel talked about performance, but with a slightly different angle. Like, I liked how when in your presentation you talked about the way people perform in architecture, and that's a very powerful image of not forgetting that there's more to this big term of sustainability. There's environmental performance, there's financial performance, there's all different kinds of performance, but also people and users, and with Kim's presentation on the mind your behavior, buildings are for people. I think that's really obvious.
Yeah, that's also where I totally agree with Ma. We are designing for 7 billion specialists for architecture. That's how we see it. And you have to absolutely respect and look for what are people looking for. Your last clients, what are they looking for? Mm-hmm. You have to absolutely analyze that and never go away from that.
I think Tobias could have talked also about, we've talked about new processes of design, changing how architecture is designed and built, but also new fabrication techniques, of course, are, that's a huge topic, and actually the output of design being buildings, technology is used in design, but also in actual fabrication, and relating to the local knowledge, I guess.
Yeah, and this is, what we try to do is actually taking all of this knowledge and what we call knowledge encapsulation or knowledge integration into really consistent models. So, if I have, and in the end, it doesn't really matter, what you're trying to systematize there. If I have particular material properties, I have particular fabrication constraints and requirements, I can actually integrate these things in really sophisticated models, and then take actually computational techniques to apply it to a variety of different, let's say, facade panels or whatever. But it's about the aspect of knowledge integration to consistent models.
Mm. Do we have time to take a question from the... Okay, we'll take a question if anyone has a question or a comment for one of the panelists? Is there a microphone? Oh, it's coming. Two of them are coming.
Yes, it works. Okay, Mr. Thomas, I just wanted to ask, you spoke about the solar panels that you are installing in Africa. So, from the point of developer view, how do you access those people from financial point? How can you find a place? Is it some charity program, or how can those villages actually afford to have such kind of units, or to start using them in the villages?
It's a business model.
So
it's not a charity project. Absolutely, I don't believe in that as a charity projects models of that size. And history proved wrong that just like doing something and going away always fails. The way it works is we're looking for bringing down the price that far, and it looks very much that we're achieving this goal. That an average kiosk pays off in 4 years. We're going to go just by the what's Kaufkraft? I'm sorry. Budget. Purchasing power that is there, that we analyzed in several different countries. So an average family, for example, pays $10 per month for kerosene, paraffin, candles, and all that crap. And if you calculate that together in a neighborhood of 1,000 families, 1,000 households, then you can sum it up and calculate how much market potential there is. So the only thing that you need to do is find a local investor to go in with you, find somebody who knows areas and who knows also the way communities are organized, and then you invest, build them, and then they're business models, and in a small scale they are creating a large network, not a network, like a number of island solutions that we hope will bypass the era of landlines and grid-based power supply, as we've seen it also in the telecommunication industry. Nobody in Africa will ever think of landlines. I mean, an era that we had here for 80 years, but there's like, I think 75% of the people in Africa have cell phones. The problem is just the charging. People walk 5 hours to the next city to charge their cell phone. But there's never going to be landlines again. So they bypassed an era that we had. We totally misunderstand development in some areas in the world. We don't take into consideration that island solutions in Africa, for example, are where they should be tested. Because nobody in Europe will test island solutions. I mean, we talk about smart grids. We don't have the need to install them, but there, it's a big chance. I hope this answers your question.
Great. Thank you very much. Thanks. Can we take one more question? We'll conclude after that. No? Okay, well, I'd like to thank all of our panelists for their really excellent presentations, and I think it's a really exciting topic, building innovation, and I hope we've all been inspired and got some new ideas about architectural design and new technologies. So thank you very much.